HR asking for the technical site schedule.
Yes, sir. Leona is gonna forward it because Leona is just the resolution.
Paano ko din
Ano
ito?
Leona is in terms of the schedule. And I asked him if I'm going to do this. She told me that this is going to be. Yes, sir. Hello? Hello?
Hello, Richard.
Yes, can we resume our training?
Sure,
Okay.
we can.
Okay.
All right.
All right.
Everyone's ready?
Yep. I think they
All
already have our lunch.
right. Okay. Uh, Let me just bring this to the starting point. Okay. First of all, any questions before we going into module 2? No? There's no question, and we can proceed. All right. Going back to the module 1 a bit, I just want to discuss about priority flow control and traditional flow control. So if you have configured DCB, which is using priority flow control, you need to use that end-to-end. Okay, so if you enable DCB on your EQL logic,
Okay.
and then enable priority flow control on the port facing the EQL logic, you need to use priority flow control that facing your initiator as well, or your server.
Okay. Sir, I have to follow questions about the link aggregation. So doing why do we need to establish a link aggregation, and what's the purpose of this on the physical on the performance of the equology
Okay.
logic?
All right, good questions. Let me bring up this slide. Bear with me. Okay. So can you see the slide?
No.
There's no.
No slides. Okay. Hold on. Bear with me.
Oh, the top.
Can you see it now?
Yep.
Okay, great. So this is typical EQL setup. Let me just unzoom it. Okay. So let me just reduce the size a bit. Uh, all right. Can you see the picture?
Yes.
Okay. So this is a typical configuration, right?
Sorry.
You have 2 switches, one EQL and then one server. This is how the cable normally cable up. So you have your port 0 goes to switch number 1, and then port 1 goes to switch number 2.
Okay.
Okay. Now, in a normal scenario, as you know, EQLogic is an active passive controller, right? So at one point, only one controller becomes active, which is, let's assume control 0 is the active controller at the moment. Now, traffic can flow through the red line and also through the blue line, right? You have your initiator, 2 ports in here. Both ports are active. Okay, so the blue line can actually reach the equal logic through switch number 1 and then through the aggregate or link aggregation to switch number 2 and then going to the red path. That's possible, right?
Yep.
Same thing. From the blue, it can go to switch number 1 and then going through this aggregate path in here, right?
Okay.
And then going to switch number 2 and then going to port number 2 or the red port in here. So that's the reason why we need this stack or link aggregate port, because the EQLogic traffic can flow that way.
Okay.
Is that answer your question?
Yes, yes. Thank you for clarifying that.
Correct. Now, in regards to priority flow control and flow control, if you have a situation where you configure priority flow control, okay, let me just bring up this page again. In this sense, right, if you configure priority flow control on this port here, let me just try to bring it up. 23 and 24, which is facing the EQLogic. Okay, and then you configure normal flow control, the traditional flow control on port 1 and 2, or port 1 in here and 1 in here, right? What's going to happen is it will not work properly. EQLogic can still see, the server can still see the volume. However, what you're going to get is a performance issue because it doesn't talk the same post frames. Because priority flow control is sending posts on a particular queue, but traditional flow control is just sending posts on one flat network. Okay, so if you want to configure flow control, make sure everything's configured flow control. If you configure with DCB, make sure everything's configured with DCB. Don't do it half-half.
Okay.
All right. Now let's talk about iSCSI initiator. There are two types of initiator. We have NIC and we have HBA. So NIC, normally we talk about a software initiator. So you have your Windows iSCSI software initiator, you have your VMware initiator. For HBA, it's actually a hardware initiator, which means all the process is handled by the hardware. What good about it is you can imagine if a particular hardware handles a particular operation, it absorbs the resources. So the resources on the hardware itself. So you have a less CPU cycle used to process iSCSI login, iSCSI communication, and things like that. Okay, we'll discuss a bit later. Now, this is a typical software iSCSI and hardware, NIC with iSCSI offload. Okay, so you can see in here a traditional network interface card. You have a hardware layer in here, which is the blue one. Let me just put my pen in. Okay, you have your NIC, and then you have your hardware, and then the remaining part, this is processed by the CPU cycle. However, if you have a network interface card with TCP offload, the NIC looks after the TCP part, and IP which is handles the routing and also TCP to guarantee that it reach the destination. Okay. Now you also have NIC that has iSCSI offload, which is part of the operation is handled by the hardware instead of the software in here. Okay, so in this kind of scenario, it will use less CPU cycle to process iSCSI information or iSCSI process. EQL Logic support all three. However, in a real life scenario, we always use a software initiator. So I've rarely seen customer using hardware, and I would say nowadays a CPU cycle used to process iSCSI information is quite low, probably about 3 to 5% CPU cycle, which is nothing. But on the old days, when iSCSI was first introduced, where CPU is very slow, this particular technology is really useful. And even sometimes by turning on TCP offload, that may impact performance. So if you notice any performance, just go back to the plain disable the offload on iSCSI and TCP. Okay, so in iSCSI communication, there are always an initiator and a target. Initiator normally a server, and target is normally a storage device. In our case, a storage device is the EQL Logic. Now, the target receive the SCSI commands and then unwrap them and then send it through the IP network and then encapsulate them. Okay, and then it respond with the right iSCSI respond back command to the initiator. So this is the typical communication again, unlike that we can see on the slide back in slide 1. iSCSI names and addressing. There are two main iSCSI addressing that we know. One is IQN and one is EUI, or Enterprise Unique Identifier. In EQL Logic, we only use IQN, okay, and it only supports IQN. IQN is a unique number or a combination of letters and number. And in EQL Logic, each target, which consists of snapshot, replica, has a unique IQN number. What we call an IQN number. We don't call it IQN name or IQN target, just IQN number. Okay. And you know yourself, the iSCSI use port 3260. IQN support all this particular operating system, so VMware, Microsoft, Red Hat, and also the EQL Logic operating system itself. Now, this is typical way you can find the IQN for each individual operating system. Okay, just bear with me 2 seconds. Oh. I'm not sure why. Okay, I'll just do this then. Okay. All right. So again, this is the way you can find the IQN number. You can see in here each EQL Logic volume has a unique IQN number, and then later on you will see that snapshot will have IQN as well. After we talk about iSCSI or IQ and name, we'll talk about the session type. So there are two main sessions available in iSCSI. First is the discovery session, which is the first session when you actually discover the target. Then you will see a normal operation session. So you cannot have the second session without doing a discovery session. So you cannot have a normal operation session without a proper discovery session. So like I said, the discovery session used to locate iSCSI target, such as volume or snapshots. The normal operation session support all iSCSI commands, and connection to iSCSI targets are via normal operation session. So this is where everything starts. It will start from the discovery. So inside your iSCSI initiator, you will have the discovery tab where you put the discovery IP. Anyone knows which IP we need to put in?
What IP?
Under discovery?
Yeah, discovery under the initiator. What
Yep.
address?
Which IP address?
The host or the storage?
Okay. When we seeing this iSCSI initiator properties, that means this is a initiator, right? So we need to discover our target.
Host. Server.
The server.
The server.
So which one is this? Which IP address is that?
The EQL iSCSI IP address.
That is correct.
Yeah.
In particular, the group IP address.
Yep.
Okay. Why? Because in EQLogic, we only care about group IP. We don't care about each individual port IP address, because the discovery IP or the group IP will then redirect traffic to different Ethernet port. We'll explain that later on the slides. But for discovery purposes, always use the group IP address. If you know MD array or MD3260, for example, MD3000, they don't have any group IP. You can pick one of the IP address from the controller, discover it, then you can discover the target. Okay. So one option is to do this, or you can actually click on the targets and then paste the target manually there. Okay. But we always recommend you to do this discovery IP. So this is how it works when we talk about target discovery. So first, the iSCSI initiator will create a TCP/IP connectivity. Then it will send iSCSI login requests. Okay, so after you put your discovery IP, it will then create a login request. And then the storage array will then respond to that. If you have a CHAP authentication, it will then negotiate CHAP. If not, then it will move forward. Okay. That's IQN validated. Yep, all good. and then it will send all the targets. The targets is most likely a volume. Okay. Then the normal operation happens, and when it's finished, it will send a logout commands and then a logout response. So if you're seeing in a log, you will see login, logout. That's normal operation in EQL logic. But if you see timeout, that's not good. Why it's timing out? It should not time out. Okay.
So meaning it's important to install the iSCSI so that the iSCSI traffic will not go to the switch to all the ports of the switch, right?
What do you mean by that?
So normally the type of switch that we always recommend to our customers is layer 2, layer 3. So I think it can also support iSCSI traffic, right?
Yeah, so in reality, right, any switches can support iSCSI. Even a Netgear switch or a D-Link switch that you purchase from a computer store, it support iSCSI. However, it doesn't react as good as a switch that designed for iSCSI. Like when you have a post frames, for example, and things like that. A switch that you purchase from a computer store doesn't actually able to hold the amount of information in their buffers. Nothing there. You still there, Richard?
Yep.
Okay. All right. So is that answer your question?
Yes, yes.
All right. So this is a normal operation of iSCSI. So after you do discovery, okay, you have your target. Then again, you have a login request. A login request normally goes to your group IP because in EQLogic or from iSCSI initiator, the only IP address they know is the group IP. Now, the job of the EQLogic in here, or the iSCSI target, is to redirect the traffic. Okay, it says here redirection may occur. Where do they redirect the traffic to? To a different network interface port or network interface card on the EQLogic itself. Okay, let's assume you have 4 ports. Normally, the group IP only tied into one particular port. Then it will check if other port is available. Is it busy or not? If it's not busy, then it will direct the traffic. Okay, so this is on a high level. So you have your login request to the group IP address. Then the EQLogic will then decide, okay, Ethernet 0 is not busy. Let's redirect traffic to that Ethernet port. Now, for example, you have your exchange. Again, my example, traffic redirect to Ethernet 0. And then the next request is for your SQL. Again, it goes to your group IP, and then EQLogic will say, okay, Ethernet 0 is busy, let's go to Ethernet 1. So that's the job of EQLogic, to decide which Ethernet port is the best to handle the request. You don't need to do anything.
It's automatic.
That is correct. Okay, so part of the EQLogic software is called network load balancing. That's where network load balancing actually doing its job to redirect traffic. Now let's configure an iSCSI target. First, going back to the discovery IP, we click on the discovery, then we click on discover portal in here. And then you will see, you will add the IP address of the target and also the port. You can leave the port as default because you cannot actually change the port, iSCSI port in EQL. Then after that, you click next or OK, and then it will come up in here. If it's not discoverable, then it will send you an error code or error message saying that there is no discovery item available, but it will still available in here. Okay, if it goes through, then you will see under your targets. So this is when it goes through properly. You will see all your targets in here, and then if you move this particular bar, you can see which volume is that target is referring to. Okay, so as soon as you, when you see this particular target, normally the target itself is inactive. Okay, like this particular one. What you have to do is to connect this particular target. So click connect, and then you can double check your target name in here. This is a volume called test volume. Okay, so each individual IQN name or IQN number in here will have a unique name like this, and also a unique number like this, right? You don't need to enable multipath because the MEM for VMware or ASM, which ASM HitKit, and then the MPIO part of Windows operating system will handle the multipathing directly. So like in here, you will have the EQL MPIO installed already. So
it automatically is enabled?
Yes.
Okay.
Okay.
What happens if you do enable it?
Doesn't really matter. Right, so after that, you will select your favorite targets in here.
Okay.
What is a favorite targets? Do you know what the favorite targets? Why we need to make sure favorite targets is, we need to put it in favorite targets?
The right hook. Anong question, sir?
No? Anyone from your team, Richard, can answer that question?
Your question is which target?
Why? Yeah. Why we need to make sure that all this IQN number is listed under favorite targets.
So it will connect automatically.
Correct. Yes. Very good. Okay. And then you need to bind your volumes as well. So what happened is this binding, so it does not report as unavailable until all your volume in here has been logged into are online. Okay, so this is important when you have multiple volumes attached to your server, and then you want to make sure that all those volumes are up first before it says, yeah, it's all good.
Nagko-connect siya, pero kailangan mo siya i-online. Hindi pa na-check. Kaya siguro.
Now we talk about basic access control. As you know, you want to put some sort of security as well to make sure that only authorized initiator can see the target. So for example, you have a volume that has been formatted using NTFS, cannot be read by a VMware operating system. So to protect that, you use an access basic access point or volume access control, right? What we can do previously on the older version, you can only create a basic access point. But now in EQLogic firmware version 7 and also even version 8, you can create access policies. So what access policy means is this. So in here, you will see access policies, right? This is a normal basic policies where you can restrict based on CHAP accounts, ISCSI initiator, IP address, and that's it. With access policies, you actually can combine that into some sort of policy. Let's look at that. So for example, you have your Exchange server. Previously, you need to create 4 entries, right? ACL, for example, you have 4 NICs in here. You put 1.1.1.1 until 1.1.1.4. And then you have a volume B. You need to do the same thing again. 1.1.1.1 till 1.1.1.4. So you can see repetition there. With, again, volume C, right? So you will see from here, you need to create 12 entries for all volumes. That's quite a huge task. If we only have 3 volumes, it's probably a small task, but let's assume you have 20 or 30 volumes. There are lots of administration tasks required. So instead of doing that, you create what we call access policies. Okay. So access policies exchange 01, which consists of 4 IP address. And if you want to create a different volume, in here, you can apply this access policy into different volumes. So instead of you doing 12 entries, you're probably doing only 5 or 6 entries. So that's reduced the amount of work for you. All right, let me bring you to the lab so we can actually have a look in real world. Okay. So we have here a normal access policies. So you have your volume called exchange, then you have your access. Right? So in here, I only have 1 basic access policies, but you can actually add in here one access policies. So exchange, and you have all exchange volumes, and you can input your IP address here.
Nagkagawa nyo na yan, yung ganyang ano.
Okay. And then what you do, you can put your exchange access policies there.
So you have to enter it once rather than multiple times.
Correct. All right. So that's how it works. Okay. Yeah. Now you will have now access policies group, which is higher than just the previous access policies. Okay. In here you will see ESX cluster. So you will have VMware host 1 with this particular IP, and then VMware host 2 with this IP. Then you're creating, normally you will have 36 IP entries for volumes, right? You can create an access policy group called ESX cluster 01, which consists of multiple access policies, which is the host level on the access policies, and then access policies group on the cluster level. All right. So if you create another volume D, and then you want to assign into your ESX cluster, instead of you putting 3 access policies, you can actually just add 1 access policies group. Okay? So that's just to help you managing your system. Now, with access control, you can have multiple entries. So in here, one example is you have your iSCSI IQN name or number, and also IP address. And the other one is using one IQN number, and then on a separate line, you will have your IP address. So as you can see in here, this one is more secure, and then this is less secure. Why is that? Richard, are you able to answer that question?
Yep.
Why the first one is more secure compared to the second one?
Through IQN, you also provided the IQN of that host server.
Mm-hmm. So in here you have your IQN as well.
Yeah.
So both have IQN, right?
Yep.
But the way you set up your access control is different. In here you have everything in one line.
Okay.
But in here, on the second example in here, you have in 3 lines. Why this is less secure compared to this? Okay. Why it's less secure is because in this example here, let me just clear this up. In this particular example, as long as it match this entry, either IQN or IP, this IP, or this IP,
Either or. Okay.
right? This is the keyword or. Then your initiator can see the target. But the first entry is N,
Okay.
right? This is N. Only when the IQN and the IP address are matched up, then you can see the target. So that's the difference between these two access policy. So make sure if you want to create a more secure environment, you follow example 1 in here, not this one. Okay? This is only numbers, so volumes allow up to 16 basic access points, up to 4 policies. Um, you need to use access policies or access policy group, especially when using MPIO, and avoid using wildcards.
Okay.
Why we should avoid wildcards?
Less secure.
Right?
Less secure.
Right, secure. So in here, if we, for example, Richard, I'm setting up my access point on 172.16 or 168.10. Blah,
Okay.
right? Why we should have tried to avoid this?
To get it will detect any machines which is in the range of that network IP address.
Great. Yep, that's exactly right. So any machine with using that IP range can actually access the target, which you don't want. You want to control that because you don't want an unauthorized host trying to see that data, right? You don't want people just, plugged in their laptop and then start writing to your storage. You don't want that. You want to make sure you control and see who is or which server can write to your storage. Now we now talk about 512 and 4K native disk support. As you know, more and more disks, especially a bigger disk, using 4K disk support. Okay, this is a hard drive physical disk formatting. So what's the difference between the two? Now, previously, you have your 512 byte sectors. You will have your, the header here, and also the ECC part. You can imagine if you have a large hard drive, there are lots of information lost for the purpose of ECC, gap, sync, address mark, and etc. Now, for a bigger disk, instead of doing this using 512, they introduced a new technology using a 4K byte sector, which means you will lose less space for this, sync, ECC, and things like that.
Okay. Is there any application with regards to the data types if we're going to use 512 type of this formatting or what?
Okay, very, very good questions, Richard. So this is backend storage format. This is independent of the front end storage format. So whatever happens in the this is only happening on the EQLogic level. So you can have a 4K disk configuration on your EQLogic, but you have a 512 disk configuration for on your front end.
Okay.
So when for your operating system, whether it's 512 or 4K doesn't matter. Okay, does that answer your question?
Let's say for example, the type of data that I'm going to store on my EQLogic is database. So
Mm-hmm.
what is the best practice type of hard drive physical disk formatting? It's like 512 or 4K?
Okay. To answer that questions, that is from the front end perspective, right? Because you're trying to access your application going to your EQLogic. But in this slides, what we talk about is how the EQLogic writes to the disk.
Okay.
So it doesn't really matter from the application's perspective because it's just writing to the EQLogic. EQLogic process this to a 4K drive and 412 disk drive. So this has nothing to do with your application. Okay?
Okay.
This is nothing to do with your application. This is only on the EQLogic level. Why I would like to explain this is because you can have a situation where you have a 4K member and 512 member, and then sometimes people swap this around and all of a sudden everything doesn't work because you cannot mix 4K and 512 disks on the same enclosure or same ecological array.
Okay.
However, you can mix between 4K and 512 member, right? So, for example, you have your PS6010 running 4K, and then you have PS4000 running 512. You can have that sort of configuration. However, you cannot have your PS6010 with a 512 disk. Because if it's a 4K disk, it needs to be 4K disk. If it's a 512, it needs to be 512. Okay?
Okay.
Right. Now, this is previously 512 and 4K native disk support. This is how a previous, prior to version 7, all volumes are presented to the operating system as 512. Now, right? In version 7, you can have 4K format disk, regardless of underlying hardware. So you can have a storage array like this, running 512, but you want to present this as a 4K disk.
Okay,
All right. Now with version 7, you can have this. So you can have mix between 4K and 512 and then just present it as a 4K.
in a single pool.
All right. To answer your question again, when you're saying, oh, when I have a database, should I put 4K disk or 512? The answer is it's not about the application, it's about the operating system. Like VMware on version 5 or even version 6, they don't actually support 4K. So even though you want to configure it as 4K, doesn't support it. As far as I know, only Windows support 5K. Again, it's kind of, for me, it's kind of a quirk where, yes, technology is there, but very a few people only use it in reality. Okay. Now, we'll talk about volume folders now. What is a volume folders? So this is how volume folders works in EqualLogic. It's a function only. It doesn't mean that you are merging DR volume or my volume together as a single folder. It's just for organization only. Okay, you can move my volume to my second folder in here, for example. Okay, just drag and drop. So it's just for, I would say, just for convenience purposes. So when you see your storage array, it looks neat, and then people understand where the volumes are, things like that. Okay. It doesn't impact, again, doesn't impact the functionality of your volumes. When you create or modify your folder, it doesn't actually impact your volumes at all. Okay, volume can belong to only one folder at a time, so you cannot have a volume that sits on two folders. To create a folder is pretty easy. Just right-click the volumes in here. If you right-click and then instead of creating a volume, you create a volume folders. Or there's a shortcut under activities here. Smart tag. Smart tag is a feature introduced in version 7. Okay, basically to help to organize search filters in EqualLogic. Previously, when you have volumes, you cannot organize it you can only organize those volume based on folders, but you cannot organize that based on application, right? With tags, you can, and then you can have more than one tag associated with your volume. So with folders, you cannot put one volumes to two folders, right? That's a limitation. But with tags, you can, because you can put, oh, this volume belongs to a volume in New York, and this is for SQL. So you can then search based on all volumes sits in New York or volumes related to a SQL database. So that's how smart tags used for, just organization, search, and filtering. This is the predefined object tags. So you have this, and then you have this. Now, this is your tag appearance, right? So you can have your under volume in here, and then you can have your volume tags under the volume level. So let's, this one is not really good. I would say let's do it on the real life better.
How do you search them?
On the search function on the top. So we'll have a look at that as well.
Okay.
Okay, so we'll have a look at this. All right, So I have my exchange volume here, and then I can modify my tag. So if I go to status, you will see tags for this particular volume is under application or database server, right? You can then modify the tag by right-clicking and then modify tags. Like I said, I can actually put multiple tags against this particular volume. So I click my location. This particular volume is in London. Okay. So I know locations in London, database server. What you can do a search in here. Find London. Okay. So you can see, find out straight away, all the volumes sitting in London, one of them is exchange. Let's say I have 2 volumes that's in London. One is called replication. Sorry about this. I have network connectivity issues in my lab. So.
So Stuart, do you want to keep this room?
Yeah, for now.
No, tomorrow, mate.
Oh, okay. Yep. No worries. Okay. Sorry about this, guys. I need to just bring up the lab again. My RDP session is just timing out.
Additional question ka pa.
All right, we're back. So this replication volume is only in London, but that's my backup. So if I search on London, I will see 2, exchange and replication. But if I search for backup, only 1, which is the replication volume. Okay, so that's how SmartX works. Probably easier compared to reading slides, right? Okay, so that's how tags works, you know that, and then search functionality, yeah. Okay, so this is to manage task, tags. In case you wanna create custom tags, you can do that is by just click on manage tags. Right, so you will have your yeah, so under manage tags in here, you can then add or modify these predefined tags. Yeah, this is search functionality. We've gone through that already. And then you can do filter as well, right? So you want to see your volumes under volume views, and then you want to see which volume is related to exchange or not. Let me just bring that up. Okay, so you will have your view in here, and then I want like to only show me volumes related to backup. So that's all. And then you'll have your,
That's cool.
okay. So this is how it works. So you basically you filter your volume.
Start mag-search ka ng
Going back to basic, how to create a volume in EQLogic is pretty simple, right? So volume in EQLogic is actually a virtualized disk. So it's a physical formatting of the disk. Volume belongs to a pool, and it doesn't actually tie up to a specific member. So you can have a volume that spreads multiple member. In our case, previously we can see that exchange volume spreads across production 1 and production 2. When you configure a volume, you need to have a volume name and then pool assignment, whether you want to put on a default pool or a different pool. And then you need to have a volume size and snapshot reserve percentage. So this is a snapshot reserve. You can see from the word reserve is a space that is conserved for snapshot purposes. This follows the pool where the volume actually resides. So for example, you have your volume sitting on your default pool. That means your snapshot will sit on the default pool as well. EQLogic doesn't support reserving snapshot in different pool. Okay. Then you have your iSCSI access, whether you want to do your basic access point or a policy or group. Okay. This is what we call LAN masking. You asked question, Andrew, before about LAN masking protection. So initiator can't actually see the target. Okay. Then you select your sector size. Okay. This is not the hard disk sector size. This is the application sector size, which is the application writing to the EQLogic. Okay, not the EQLogic writing to the disk. Now, if you don't have the option here, that means your array only support 512. But with a newer firmware, you have the ability to actually select whether you want a 512 or 4K, even though your underlying storage only support 512. Right, this is how you do it. From the GUI, you click on volume, right click, create volume. Okay, you can do that, or you can click under your activities bar in here. That's the way you create volume. 6 steps. Right, so you have your volume name, volume size, and then snapshot reserve.
I think the snapshot reserve, the other one said that it was 100%.
Yes, it's
Does that mean that it's 100% snapshot ready, or?
it's actually allocating 100% of the reserve space.
Okay. All right.
So if in this scenario, right, we have a 1 gig volume size, and then we have a snapshot reserve of 100%.
sa tubig yung malaki.
Right? Because this is a thick provision. How do I know whether this is a thick provision or thin provision? This is the one. Okay. So if you see this is fully allocated like this, that means is a tick provision.
Yeah.
If you only see partial like this, normally it's a 10% of the space, that means a thin provision.
Okay.
Because you are allocating the whole lot for your tick provision, that means your snapshot reserve, which is 100%, becomes 1 gig. So you will see in here your new, okay, you have this one. Your volume reserve is 1 gig, and then your snapshot reserve is 1 gig.
So total.
Okay? You will see different behavior when you configure thin provision.
Thick and thin.
Thick and thin. So you're pre-allocating space to your storage. So, but not just an allocation, pre-allocation.
Steve?
Team
What's the
provisioning is that you allocate, let's say, 10 gig. Then when you need another size, you just adjust the bar so that there is a volume on it. It can be adjusted. Or
So
can
in total, when you use snapshot, that would mean that you're using
Normally, when we assign
No, a snapshot doesn't use 2 gig.
so let's say,
We'll explain about
uh,
snapshot, but that's only volume that's reserved
just
for
Yeah.
snapshots.
occupy
Alright.
10 gig.
Oh,
Okay.
okay.
The snapshot itself is pretty small,
Yeah.
But since
and then when there is a delta changes,
in
then it will then consume the space.
Okay.
only some
All right.
or portion of,
Um,
let's say for example, the 2 gig is just used in your storage, so 2 gig
Richard,
just thin provision.
you okay, or do you want me to explain about thin provision?
Yes, can you elaborate more what is thin provision and what's the advantage of between thin and thick?
Okay, sure. So a thick provision, like I said before, it's a pre-allocated space. So it's a reserve. So you know that your volume is actually taken from your free space pool. So in case you have a 10 gig, this is example of free space in your pool, then it will then allocate 1 gig for volume and then 1 gig for snapshot. So in theory, you only have now 8 gig free space, right?
Okay.
But in a thin provision situation, it's different. Hold on. Okay, you actually presenting 10 again. This is again 10. You're presenting 1 gig volume to an operating system, but you only allocate 10%, which is 105 meg. And then as soon as the volume getting bigger and bigger, it will then start allocating more space. Okay, so for example, you have your volume size getting bigger to 500 or 300, then it will allocate 400 here. Why it's good? Because you can imagine you have a company that's growing. You don't want to invest 10 terabyte or 20 terabyte of storage upfront because you don't use it. You probably, as a startup company, you probably use only 100 gig for your VMs, for your file server, Exchange. But as soon as the company grows, the database will get bigger and bigger.
Sorry,
But
please correct.
sorry?
I have questions. So there are applications which we really required to to implement for tick provision. So what's the reason behind that?
Okay.
Because according to them, if we're going to use a tick provision, let's say for example for this specific database volume, the performance is much better compared to the thin provision volume.
Okay. Yes. In an older system, that's the case. This is because when you have a thick provision and you format it, it will then zero it. So you probably know in VMware, thick provision lays thick provision eager zero,
Yeah.
right? Basically, what happened is you format that particular volume and you zero everything. So that 1 TB is zero, ready to write. With thin provision, is not the case. It will only zero the first bits. Whatever allocated, they zero it. And then when it needed, then it's needs to zero it that particular sector or particular page. That is why people say that, oh, thick provision is better because you already zero it. Then when you need to write, you just need to write instead of zeroing it again. But in thin provision, before you can write, you need to zero it first.
It's got an extra overhead.
Correct.
Yeah.
Is that answer your question, Richard?
Yep. Thank you.
Okay. Now, in EQLogic though, even though you configure as a thick provision and then VMware will, you configure your volume as a thick provision lazy zero, EQLogic will not actually zero it because it only pre-allocate that particular space. So you can change from a thick provision volume to a thin provision volume by just unticking this box in a real life. And then you will see a space actually remove from reserve and becomes whatever it consumed. That is how good EQLogic. So this is useful when you have a situation where you're running out of space and then you have allocated too much space on your other volumes because you want to configure it as a thick provision. Okay, so what you need to do, right click on that volume, change it from thick to thin, and then click apply. It will not impact your production. It will not cause any issues on your application at all. Right? So like I mentioned earlier, if you're seeing this where only 10% is allocated, that means you have a thin provision. But if you have everything's allocated, that means you have a thick provision. Now, do you see the difference here? When you have a thin provision, you will see reserve space 105. The snapshot reserve is percent of volume reserve, which is the 100% of 105 meg. So the snapshot reserve is calculated not from the size in here, but from here. That is really critical. Right, so then you can select your access access policy, right? You can use an existing one or you can create a new one. So in here, I select the existing access policies and then hit add, and then this is important as well, simultaneous access to this volume. What does this mean? What do you mean to allow simultaneous access? What is it useful for?
Simultaneous access, meaning for multiple users are going to access the same volume.
Okay, yeah, very close. It's not a user. It's actually an initiator. That's the right terminology. Okay. See, one more than one iSCSI initiator. Typical configuration is cluster. Because cluster, they're aware of each other. So you have your ESXi cluster. You want to have your redundancy. It's accessing the same volume, but you want to have HA. So in case one host dies, all your VM falls over or failed over to different hosts. So that means both hosts needs to have access to the same volume. Both hosts needs to have simultaneous access, right? However, if you don't have a cluster a server situation, you don't want this to happen. You need to turn this off. Why? Because you don't want multiple servers trying to access your data store. It doesn't understand what the other operating system is doing. What if one operating system is trying to write and the other one is trying to delete that file? You have corruption. So make sure you only enable this simultaneous connection when you have a cluster situation.
Okay.
Okay. Then after that, you have the option to assign tags. You know what tags is? Then you have your sector size. Again, the sector size is the application. It doesn't actually relate it to the disk, right? Make sure you read this. Operating systems may not support 4K sectors volume, like VMware, for example. Then that's it. It's just giving you summary, and you had finish, or you click finish. We already discussed this, multiple host access, okay? You have a cluster, you have a multi-path solution, does not use the same IQN on all initiators.
Excuse me,
And then you have,
Alan.
Excuse me. Excuse.
Hi, Alan.
yes,
We have question.
sure.
Okay. For your 512, on the volume, right? You created the volume, then there's a sector size.
Yep.
Okay. So can I have, let's say, multiple volumes with 512, then another volumes with 4K?
Yes, you can.
So it would depend on the application. It's either if I use 4K, it would depend on application. Let's say Windows.
The it depends not on the application, more precisely on the operating system, whether the operating system can actually accept it or not.
It would depend.
Okay, so would you recommend if I use 4K for the new volumes that I will create?
Uh, it will depend on your operating system. If your operating system support 4K, go for it.
Let's say, for
But
example, it's Windows. Definitely, it would support for
yeah,
4K.
yeah. But I myself, I haven't actually seen lots of
The-
improvement using 512 or 4K.
So there's much
Um,
difference.
not much. In theory, I haven't seen if you after performance, no difference between 512 or 4K. You probably need to look at a specific application or operating system to see, hey, what's the 4K benefit for this particular application. There's a most likely there's a white paper somewhere saying that 4K is better for SQL, for example.
Okay.
Okay.
Okay. Thank you.
But yeah, you can have mix between 512 and 4K.
Okay.
Okay. Right, and after that you will see a volume. Volume by default is when you create it, its or status is online, which is showing up like this. When you have volume showing up like this, like a gray, or it's not, it's kind of a shadowish color, that means that volume is actually offline. Okay, so in here offline. Now, volume online, it doesn't mean that a particular host can actually access it. Good example, when you set up your volume, going back to the previous slides, where is it? You don't set up your access point or access list, right? You select this. None, do not allow access. That means you create the volume, but no initiator can access it.
Just for testing.
Okay. A good example for that is for example, you have a pre-allocated task, a pre-allocated project. You want to make sure that in 2 months' time, I have 20 gig volume. You don't want any host to have access to that volume because you haven't purchased one, and then you don't want anyone to write to it, but you want to make sure that I have that 20 gig or 200 gig in 2 months' time. So you can actually pre-allocate a volume and then set up or setting it up so no access, and then 2 months' time, you can just modify that volume and then assign the IQN or IP address based on the new server that you provision. So that's one example where you don't want to give access straight away. Okay, and after that, after you've done your creation of your volume in EQL Logic, you go to your iSCSI initiator. Following the previous steps, you discover it, discover your EQL Logic, you see your target, and then you connect your target. As soon as your target disappears, it says connected, then you go to your disk management, and then do refresh, and then you will see your EQL Logic disk in here. You need to do just online it, initialize it, and then format it.
And
Okay, so we'll have lab 2 and lab 3. We're gonna do send HQ. Okay, MPIO first, actually. We still have, yeah. So let's talk about MPIO. What is what MPIO stand for? It's actually multipath IO. The purpose of MPIO is improve the performance. 2 seconds, guys.
nothing to worry.
Okay, so going back to MPIO, it improves performance. It eliminates a single point of failure between server and send. So if you can see from here, you have your server with MPIO. In case one path goes down, so for example, you have 2 switches in here, right? One path goes down, this one goes. MPIO will then forward the traffic to the other path. So that's the job of MPIO. Provides a higher level of availability, connection management. Okay, so in Windows you have different type of MPIO. You have round robin, list QDAP, and things like that. So those MPIO has a different smart behind it. So round robin, for example, is just used very simple way. Send one traffic here, then send traffic here. Okay, so first traffic goes to red, second traffic goes to green, third traffic goes to red, fourth frames goes to green, right? That's how it works. With list QDAP, it's a bit smarter. It understands whether the other path is actually busy or not. If it's busy, then it will use the same one. Oops, where's my... Okay. If it's busy, then it will use the second one, right? That's how this QDAP works. In VMware, it's all different. You have your round robin, you have your fix, you have your and then you can have actually a specific for EQLogic MPIO, which is EQL routed. That's EQLogic MPIO for VMware. But in Windows, EQLogic will use list QDAP. All right. It works with any combination of NICs and HBA. So for example, you have your Intel and Broadcom on the same server. You can have MPIO like that. However, it's not recommended when you have a multiple vendor as your initiator. Okay, better to use the same one. It aggregates performance, yes, because MPIO is using multiple paths. So in ASM, you can see how many connections you can create per volume slice. That will increase the volume, increase performance, because imagine you have your download manager, for example, right? If you download a software from, let's say, an FTP site using one stream, it's probably slower than you create multiple streams. Same thing with MPIO and EQLogic. If you create multiple connection to your EQLogic, you will get better performance. And then you have your connection aware MPIO for Windows. All right. Yeah. So that's pretty much the main purpose of MPIO. MPIO settings, you have DSM, which is the terminology when we talk about Windows. The service that serves MPIO purpose is the DSM service. Okay. You will see that this is the default settings. Maximum session per volume is 6. Maximum session per volume slice is 2. Because EQLogic by default, if you have a multi-member group, one volume can sit in 3 members. Maximum I've seen is 4, but in real life, EQLogic will only spread a volume to maximum 3 to 4 members. You cannot have a volume that sits, even though you have 8 members, for example, a volume spreads across 8 members. I haven't seen that. Okay, so again, maximum is 3 or 4 maximum. This is where you set up your maximum session per volume. So this is the number 6 in here, and then this is the number 2. Okay. Then what you need to look at is the IP. As you know, you are using multiple subnet normally in a real life. You have your iSCSI subnet, and you have your production subnet, and then probably you have another subnet for something else. But a typical scenario is you have 2 subnets. In here, you will see that EQLogic will use 1 subnet, and then you put it in the included section here, and then you can exclude your production network, the one that's showing up in here. Okay. What will happen is EQLogic or the MPIO software will not try to create session using this particular adapter and this particular subnet. Now, this is a feature in Windows. There is nothing to do with VMware. It's called ODX. Anyone knows what ODX means, or what ODX is? Richard or your team member knows what ODX is? Yeah, can you explain to me what ODX? In a real, a simple way. If you're not comfortable, let me know. No? Okay. All right. So ODX is a simple term, is you are utilizing the EQLogic software to do the hard work for you instead of the operating system. When you have a normal scenario, you have your server here, right? You have your volume, let's say volume A, and you have volume B. And then you want to copy your data from volume A to volume B. The traffic will go to your operating system, and then from the operating system goes to B. However, with ODX, it basically sends a message or information to your storage array. In here is EQLogic, saying that I want to copy a file A that sits on volume A, goes to B. Right? So basically, instead of traffic going that way and then that way, it actually goes that way, just inside the EQLogic. What the good thing about that? First, you don't make your iSCSI network busy, right? So there's less traffic in here. The second thing is you have a storage array that's quite powerful. So why don't you use its CPU cycle to do the work instead of wasting CPU cycle in here in your server for doing something else? So that's pretty much how ODX works.
Alan, excuse me. Alan,
Yes.
yeah. Is your volume? Are you talking about the volume residing on the same OS or the same physical server, or it can work on two servers, like transferring volume to volume.
Two servers transferring volume to volume.
Volume A for server 1, then volume B for server 2. Then I want to copy the data from server 1 to server 2 or volume A to volume B. Does it really go to the within iSCSI, within EQL only, or it will have to pass through the OS?
In that case, if you're talking about a different server,
Yes.
then it needs to go through the your network, your production network.
Although
If
it
it's
resides on the same EQL?
Just hold on. Sorry?
It's on
So
the same
let me
EQL, right? It's on,
no. So for example, I have two servers here.
yes, okay.
Server 1, server 2. And you have your equal logic here. Right?
Okay.
You have your volume A. And you have your volume B. Volume B is connected to that. Volume A connected to that. In this kind of scenario where this is independent OS, right?
Okay.
This is 2008. This is 2008. And then if you want to copy file from A to B, you need to go through your production network in here. Okay, you cannot ask EqualLogic to actually send from A to B because this is two independent operating system.
Okay.
Okay, but if you have a cluster like that, right, then EqualLogic can send traffic directly. Okay?
Okay.
If it's on two equal logics, so if A is on one equal logic, B is on the other, can it do it just between the two equal logics, or does it have to go?
Okay, so we have a question here. For example, you have a server here, right? You have a Windows server here, and then you have two equal logic. Is this two equal logic on the same group or different group?
Same group.
Okay. If it's the same group, is it on the same pool or different pool?
Different pools.
Different pool, you can't.
Okay.
Okay?
Yeah. But if it's in the same pool,
You can.
that's cool.
Okay? So,
Alright.
okay. Windows will use ODX by default. Windows makes the one, yeah. So this is the supported disk types: VHD, network file shares, and physical disk. So you cannot have other than this supported disk type. So this is the key TCP and UDP port that EqualLogic use. Important one is 80 for accessing the group manager, SSH to actually access the EqualLogic via 22 for SSH, and then you have 161 for send HQ. 3260, of course. And then this is important as well. Okay. The remaining ones, this one, yeah, you know, you can disable FTP if you want. It's not being used for any operation purposes. SMTP is just for sending email alerts, and then syslog. Okay. Telnet, it's not really secure, so I prefer SSH. And yeah, this is the other two as well. Okay, important. All right. So we'll probably go to SendHQ right now. And then after that, we'll finishing up with lab. So we have a few lab to do, okay? Do you want to take probably 15 minutes break?
Sure. Sorry, sir. Emergency kasi.
Okay, and then if you have questions or anything is not clear, just raise it before we start into
Question.
topic number 3. Okay.
Breakdown.
All right. See you in 15 minutes.
Okay. Any questions? Sir Milan.
Siyempre, po.
Stop or pause?
Sir Milan, asensya na.
Pause na lang.
Ano?
Any question as Sir Emil or Sir Chris?
Sir.